Hi, good morning. In today's video, I'm going to do this problem. Let S is defined as a set of positive integers, the numbers from 1 to 2017. Let A sub 1, A sub 2, A sub 3, and so on, until you get the last term 2017, be positive distinct integers are having its values in the same set. Okay, so the first question, prove n, capital N, equal to the product of A sub k minus k is an even number. Okay, what does distinct mean? Distinct are the numbers not equal to each other. Okay, so every number is different than the other. Okay, and positive this means is bigger than or equal to 1. Okay, is strictly superior than 0. That means positive distinct. Okay, and having its values in the same set. Okay, all the numbers values of these numbers, which are E sub 1 to E 2017, are in this set, which is the first one, as the numbers from 1 to 2017. So all the numbers are in this set. Okay. Now let's start solving this problem. Start with the first question. I'm going to prove this number capital N equal to the product A k minus k is an even number. K from 1 to 2017. Okay, 2017. In this question now, I cannot say E sub 1 equal to 1 or E sub 2017 equal to 2017, because we don't know, we don't have any idea, any information about it. Okay, so but all the numbers are in the same set. What does this mean? That means the sum of these numbers are equal to the same numbers in the set. What does it mean? The sum of these numbers A sub 1 to A sub 17 from K, the sum of these numbers equal to the numbers that you have in the set. Okay, let's express this one. That means the sum of A sub k, or say A sub I, for example, I from 1 to 2017 is equal to the numbers in the set I from 1 goes from 1 to 2017. Okay, also I can write the product of these numbers are equal to the product of this set. Okay, so this is very important. Okay, let's move on to express this identity, to see what is this. What does mean these numbers? As you know, in general, the integer number is a component of even numbers and odd numbers. Okay, let's express that. That means this sum, I can rewrite it on this form: 2i plus 1, I from 1 to 1008, not 2000, because I'm going to divide the numbers, even number and the odd number separately. Okay, plus the even number I can rewrite on this form: 2i, I always from 1008. Okay, plus number 1. because when I plug number 1 into this one, I start with a sub 3, not a sub 1, okay? 2 multiplied by 1 is 2, plus 1 is 3. The same thing here. When I apply 1, it gives me a sub 2, the first term. That's mean, but we have these terms from 1 to 2017. I can rewrite in this form. 1 plus this one equal what? Equal to this one. The same thing. This one equal the same thing. The sum of 2i plus 1, the odd numbers I from 1008 plus the even number 2i from 1008, okay, plus number 1. This one it will be cancelled out, number 1, okay. So what's left? This one. Sum of a sub 2i plus 1, it goes from 1 to 1008 plus I sub 2i, I from 1008 equal to this one, 2i plus 1, because the odd number, this is the form of odd number, always 2i plus 1, plus this one, 2i, I from 1008. What's my goal of writing this one on this form? My goal, because I don't know exactly 2i plus 1, a sub 2i plus 1 is an odd number or even number, okay? By writing this equation, I can know it by right hand side of this equation, because the right hand side of equation, we know the numbers 2i and 2i plus 1. I know the number sum of 2i plus 1 is an odd number on the right hand side of the equation, equal to the even number on the left hand side of the equation. Okay, I'm going to match the numbers. Number even, okay, implies on the left hand side of the equation, which is sum of 2i, I goes always from 1008, is an even number as well. Okay, is an even number. Same thing with the odd numbers. Sum of 2i, sum of a sub 2i plus 1, okay, I goes from 1 to 1008, equal, is an odd number, is an odd number, implies sum of 2i plus 1, same thing with the odd numbers. Since we have 2i plus 1, I goes from 1008, okay, is an odd number, implies the odd number is located on the left hand side, of the equation, is an odd number as well. So a sub 2i plus 1, I goes from 1008, is an odd number. Now this product, I'm going to change to I, because all the equations I equal to a minus 1. I can take this a1 minus 1 outside of the product because it is cancelled as a constant. Okay. So we have this is odd number, this is the even number. Okay, we already proved a sub to I plus 1 is an odd number, right? Okay, now this one, since we have this product, the difference of the odd number, what is this? The difference of odd number is an even number. Okay, because let's take for example 7 minus 1. Okay, 7 minus 1 is 6. 6 is an even number, so that's mean the difference of two odd numbers is the even number. The difference of the even numbers is always even number. 4 minus 2, 6 minus 4, 8 minus 6. Okay, that's mean since the product of 2, that's mean I to I plus 1 minus 2i plus 1, I sub 2i plus 1 minus 2i plus 1, the product of 2i plus 1 minus 2i plus 1, and 2i minus 2i, that means the even number, because even number multiplied by even number is giving you always even number. Okay, eight, that's mean 2 multiplied by 2 is 4, 4 multiplied by 2 is 8. I can replace this one, since this one is an integer number, I can replace it by 2p. Okay, finally this is the even number, okay, because we have 2p. The first question is verified. Let's move on to the second question. I'm going to prove this sum of a sub I square minus I square over I superior or equal to 0. Okay, so in this case I'm going to use by induction as a proof. Okay, let's start with to verify the first term for I equal to number 1, so let's plug in number 1 into this product. We have 1 a sub 1 square minus 1 square over 1 square is equal to a sub 1 square minus 1 equal to this one, equal to a sub 1 minus 1 factor a sub 1 plus 1. Okay, since we know the minimum a sub 1 can take number 1. Okay, so a sub 1 is always superior or equal to 1. Okay, because is the set start is from 1 to 2017. Since all the values of these integers, distinct numbers, are in the same set, that's mean it will take one of those values. Okay, the minimum can take number 1. Okay, that's mean a sub 1 is always superior or equal to 1. Okay, since we know a sub 1 superior or equal to 1, equivalent a sub 1 minus 1 superior or equal to 0, and also a sub 1 superior equal to 1, that's mean a sub 1 plus 1 superior or equal to 0. So that's mean since these numbers are positive, we are going to do the product of this one. So that's mean the product a sub 1 minus 1 multiplied by a sub 1 plus 1 superior or equal to 0. Okay, the first condition is verified. So for the number I equal to 1, so the first term I equal to 1 is verified. We are going to suppose that this inequality is superior or equal to 0 by induction. Okay, proof. We suppose that the sum of a sub I square minus I square over I from 1 2017 is superior or equal to 0 by induction proof. Okay, this induction proof, always before you apply this one, we have to verify first term is correct. First term. Okay, let's move on to this one. This one we are supposed that this one superior or equal to 0. We are going to prove that sum of a sub I square minus I square over I from, it goes from 1 to 2018, okay, is superior or equal to 0. That's the by induction. We are going to suppose for n is correct. Okay, that's true statement. We are going to prove n plus 1, the same thing. So 2017 is the last number. Okay, so that's mean n plus 1 is 2000. I'm going to prove this one. If I prove this one, that's mean my job is done. Okay, let's move on to prove this one now. This one plus another term, because just plugging 2018 into this one is giving you this one. Once I prove this one is superior or equal to 0, that's mean my statement is true. Okay. Why I put 2 times? Because I subtract 2018 from this one is giving you this one. Okay, one just adding 2018 square, and same time I'm subtracting the 2018 from the same number. Okay, from the double is the same thing. Just I'm going to write this one on this form. That's why I put it this one like this. Okay, this one, what is it? Superior or equal to 0. Superior or equal to 0. Why? Because we have quantity square. Okay. number 2 and multiply by 2018. Okay, factor A sub 2018 minus 2018. Okay, in the same time I'm going to divide by 2018 by on both sides. Okay, because we have here, I'm going to write this one as is it here. A sub 2018 square minus 2018 square over 2018 superior or equal to 2 times A sub 2018 minus 2018. Okay, now I proved this one. It's just superior or equal to this one. Now let's move on to the next step. Okay, this one we supposed to this one superior or equal to 0 as we put it before, because by induction. So this one we know A square minus A sub I square minus I square over I goes from 1 to 2017. We know this one is superior or equal to 0. Okay, the other side, I square over I goes from 1 2017. From 1 2017, I'm going to simplify by I. Okay, so an equivalent I square over I square. I goes from 1 to 2017. Okay, superior or equal from I goes from 1 2017. Okay, see this one, I can take off the sum from both sides. Okay, as long as I can apply a sum, okay, I can take it off as well. Same thing with the product, this is true. Okay, you can do it. Okay, we're gonna take off the sum of these numbers from both sides. Okay, so this one is giving us I square. Since these numbers are positive, okay, so that's mean this one you have two cases. You have A sub I superior to I, and you have A sub I superior to minus I. Since I is a positive number, because I is always superior or equal to 1, so we are taking the first one. A sub, that's mean implies A sub I superior or equal to I. So insert 2018 into I here. So that's mean A 2018 superior or equal to 2018 equivalent A 2018 minus 2018 superior or equal to 0. Okay, now I prove it. This one, we prove this one superior or equal to 0. So this one, that's mean A 2018 square minus 2018 square over 2018 square superior or equal to 0. Okay, so now it was positive because of this one. A sub 2000, it is always superior or equal to 2018. Let's assume this is positive. This is the whole thing positive. Now I prove it, okay? So the sum I except square minus I squared over I goes from 1 to 2017, okay? Superior or equal to 0, okay? By induction proof. This is the good place where I can stop. Thank you for watching. I will see you in next video. Bye.